There are diamonds the size of Earth floating in space, dead stars that shouldn't exist, and places where a single second lasts forever.
Everything I'm about to tell you sounds impossible. Sounds like the fever dream of a science fiction writer who gave up on realism entirely. But every single fact in this video has been verified by scientists, documented in peer-reviewed research, and confirmed by direct observation. These aren't theories, these aren't maybes, these are things that actually exist in our universe right now. And by the end of this video, you're going to realize something uncomfortable. Reality is far stranger than anything we could have imagined. The universe doesn't just bend the rules, it breaks them. It violates our intuitions about what should be possible. So let's count down 10 facts that will fundamentally change how you see the cosmos, starting with something that seems merely strange and descending into the truly incomprehensible. Imagine a planet, but it doesn't orbit a star. It just drifts through the darkness of interstellar space forever. These are called rogue planets, and they're not rare anomalies. According to recent studies, there might be more rogue planets in our galaxy than there are stars. Think about that. The Milky Way contains roughly 200 billion stars, which means there could be hundreds of billions of planets wandering through the void with no sun to warm them, no day, no night, just eternal darkness and cold approaching absolute zero. Some of these worlds were ejected from their solar systems during formation. Gravitational chaos flung them into the cosmic abyss. Others might have formed alone, condensing from gas clouds without ever having a parent star. And here's what should disturb you. Some of these rogue planets are probably Earth-sized. Right now, there could be dozens, maybe hundreds of frozen Earths drifting through the space between stars, their surfaces locked in permanent night, ice kilometers thick, covering oceans that froze solid billions of years ago. They're out there, right now, moving through the darkness, and we've only detected a handful of them. 400 light-years from Earth, there's a cloud of methanol, the same alcohol used in racing fuel, that's 1,000 times the diameter of our solar system. This isn't a small puddle. If you could gather all the alcohol in this cloud and convert it to beer, you'd have enough to supply every person on Earth with 400 trillion pints each. For perspective, that's enough to keep the entire planet drunk for several billion years. The cloud exists because complex organic molecules form naturally in the dense, cold regions of space. Methanol is created when carbon monoxide and hydrogen react on the surface of dust grains. It's chemistry, pure, simple chemistry happening on a scale that beggars imagination. But here's the truly strange part. This isn't the only alcohol cloud we've found. Space is full of organic molecules, amino acids, sugars, even compounds that smell like raspberries and rum. The building blocks of life aren't rare cosmic accidents. They're everywhere, floating in clouds larger than solar systems, which means either life is far more common than we think, or the universe is playing an elaborate joke on us, filling space with the ingredients for life, but leaving most of it unused. There's an object in space called PSR J1748-2446 AD. It's a neutron star, the collapsed core of a dead sun compressed to the point where a teaspoon of its material weighs 4 billion tons. And it spins 716 times per second. Let me put that in perspective. This object is 20 kilometers wide, about the size of a city, and its surface is moving at roughly 24% the speed of light. If it spun just 15% faster, it would tear itself apart. The centrifugal force would overcome gravity and the star would explode. But it doesn't. It exists right at the edge of physical possibility, spinning so fast that time dilation effects become measurable. A clock on its equator would run noticeably slower than a clock at its poles. Here's what's disturbing. We don't fully understand how neutron stars can spin this fast. The physics works, barely, but the formation mechanism that creates such extreme rotation is still debated. Some event in the death of a massive star created an object spinning faster than anything else in the known universe. And it's been spinning like that for millions of years. A cosmic gyroscope that shouldn't exist, rotating at a speed that would destroy ordinary matter instantly. Stable, unchanging, impossible.
In 2004, astronomers discovered something remarkable. A planet called 55 Cancri E, roughly twice the size of Earth, orbiting a star 40 light-years away. And it's made largely of diamond. This planet was once part of a binary star system. When its companion star died and became a white dwarf, it stripped away the outer layers of 55 Cancri E, leaving behind a core rich in carbon. Under the immense pressure and temperature, that carbon crystallized. The surface is likely graphite, but beneath that lies a mantle of diamond, potentially thousands of kilometers thick. We're talking about a world where diamond isn't a precious gem, it's common rock, where the ground beneath your feet would be harder than anything naturally occurring on Earth. But here's the truly alien part. The surface temperature is roughly 2,400 degrees Celsius, hot enough to melt steel. This diamond planet is tidally locked to its star, meaning one side faces eternal day, the other eternal night. The day side might have rivers of molten graphite flowing across diamond bedrock, a planet worth more than the entire economic output of human civilization, made of material we value as the ultimate symbol of rarity and luxury. And it's just there, common geology on an alien world.
In 2011, astronomers discovered the largest reservoir of water ever detected in the universe. It surrounds a quasar 12 billion light-years away, and it contains 140 trillion times more water than all of Earth's oceans combined. To be clear, this isn't liquid water. It's water vapor suspended in the environment around a supermassive black hole. The cloud is hundreds of light-years across, and the water molecules are being energized by intense radiation from the quasar. But the amount is staggering. You could fill Earth's oceans 140 trillion times and still not use all the water in this single cosmic cloud. Here's what this tells us. Water is not special. It's not rare. It's one of the most common molecules in the universe. Hydrogen is the most abundant element. Oxygen is created in massive stars. Combine them and you get water. It's everywhere. Which means the universe is full of the essential ingredient for life as we know it. Vast oceans worth of water floating in space, orbiting dead stars, locked in comets, buried in moons, suspended in clouds around black holes. And yet, as far as we can confirm, we're still alone, surrounded by water, surrounded by the ingredients for life, and we haven't found anyone else.
In the 1990s, astronomers discovered a star called HD 140283. After careful analysis of its composition and brightness, they calculated its age, 14.5 billion years old, give or take 0.8 billion years. There's just one problem. The universe itself is only 13.8 billion years old. This star appears to be older than the Big Bang, which is obviously impossible. For years, this was called the Methuselah star paradox. Scientists recalculated, they checked their instruments, they refined their models of stellar evolution, and slowly the error bars narrowed. With better measurements, the star's age came down to roughly 14.3 billion years, with an uncertainty of about 0.7 billion years.
which means, within the margin of error, the star could be 13.6 billion years old, just barely younger than the universe. Problem solved, right? Except the upper end of that error bar still places it at 15 billion years old, older than everything. The most likely explanation is that our age estimates for the star are slightly off, that there's some factor in its composition or evolution we haven't fully accounted for. But we can't be completely certain. And that uncertainty reveals something unsettling. Our models of cosmic age, stellar evolution, even the age of the universe itself, are only as good as our measurements. We're confident, but confidence isn't certainty. There might be things in the universe that predate the universe, and we can't completely rule that out.
In 2007, astronomers discovered something that shouldn't exist, a region of space nearly 1 billion light-years across that contains almost nothing. No galaxies, no stars, no gas clouds, no dark matter, just emptiness. This is called the CMB cold spot, and it shows up as a strange, cool region in the cosmic microwave background radiation. The current leading theory is that it's a supervoid, an enormous, underdense region of space where matter is distributed far below average. But here's the problem. Standard cosmological models suggest voids this large should not have formed in the time since the Big Bang. The universe isn't old enough for structure to develop at this scale. Some physicists have proposed exotic explanations, that it might be the imprint of another universe colliding with ours, that it could be a topological defect in space-time itself, that it might represent something even stranger. Most likely, it's just a statistical fluke combined with complex dynamics we don't fully understand yet, but we can't be sure. What we do know is this: there's a hole in the universe nearly 1 billion light-years across, a void so large that if you were somehow placed in its center, you wouldn't see a single galaxy in any direction for hundreds of millions of light-years. You would be surrounded by absolute, perfect darkness. No stars, no light, nothing but the faint glow of the cosmic microwave background. And you would be utterly, completely alone.
Here's something that sounds like philosophy, but is actually hard physics. Time is not universal. It doesn't flow at the same rate everywhere in the universe. This is time dilation, predicted by Einstein's general relativity and confirmed by thousands of experiments. Time moves slower in stronger gravitational fields. A clock on the surface of a neutron star runs measurably slower than a clock in interstellar space. A clock near a black hole's event horizon runs slower still. But here's where it gets truly strange. This means different parts of the universe are experiencing different amounts of time. Since the Big Bang, some regions have experienced more time than others. If you could somehow watch the entire universe at once, you'd see some galaxies aging faster than others. Stars in low-gravity regions burning through their fuel quickly. Stars in high-gravity regions burning more slowly. Time itself moving at different rates depending on local gravitational fields. And at the event horizon of a black hole, time dilation becomes so extreme that from an outside perspective, time appears to stop completely. An object falling into a black hole would appear frozen at the event horizon forever, never quite crossing. From the object's perspective, it falls in normally, but to us, watching from outside, it never completes the journey. Two equally valid perspectives on reality, both correct, both describing the same event, both completely contradicting each other. This isn't a thought experiment. This is how time actually works. WASP-76b is a planet 800 light-years from Earth. It's a hot Jupiter, a gas giant orbiting extremely close to its star. The day side temperature reaches 2,400 degrees Celsius. The night side is roughly 1,500 degrees cooler. And because of this temperature difference, the planet has weather, specifically iron rain. On the day side, the temperature is hot enough to vaporize iron. This iron vapor is carried by powerful winds to the night side, where it cools and condenses into droplets. And then it rains, liquid iron falling from the sky. Imagine standing on the Terminator line between day and night on this world. Behind you, eternal daylight hot enough to boil metal. Ahead, eternal darkness. And in the twilight zone where you're standing, the sky is raining molten iron. Each droplet would be several thousand degrees. The air would be thick with vaporized metal. The wind would be screaming at thousands of kilometers per hour, carrying the heat of the day side to the night. This isn't speculation. We've detected the iron signature in the planet's atmosphere using spectroscopy. We know it's there. We know it's happening. There's a planet where the weather forecast includes iron rain, where geology and meteorology merge into something alien, where the sky itself is made of vaporized metal. And it's real.
And now, the most disturbing fact of all. One that challenges not just our understanding of space, but the very fact that we exist to ask questions about it. When matter and antimatter meet, they annihilate each other. Equal amounts of both should have been created in the Big Bang. They should have immediately annihilated each other, leaving behind a universe of pure energy and nothing else. But we are here, which means there was slightly more matter than antimatter, about one extra particle of matter for every billion matter-antimatter pairs. That tiny imbalance is the only reason anything exists. Stars, planets, galaxies, you, me, everything we've ever seen or touched or measured, all of it exists because of a 0.0000001% asymmetry in the early universe. We don't know why this asymmetry exists. We've detected tiny differences in how matter and antimatter behave, but not nearly enough to explain the imbalance. The standard model of particle physics has no mechanism that produces the ratio we observe. Which means either there's physics beyond the standard model we haven't discovered yet, or the universe we see is the one survivor of countless parallel universes that annihilated themselves completely, or there's something fundamentally wrong with our understanding of the Big Bang. Think about what this means. Everything that exists, every atom in your body, every star in the sky, every galaxy in the observable universe exists because of an unexplained asymmetry, a cosmic accident we don't understand. We are living in a universe that, according to our best theories, shouldn't exist, and we have no idea why it does.
Planets made of diamond, stars older than time, voids a billion light years across, asymmetries that shouldn't exist but allow us to exist. Every fact I've shared with you today is real, documented, verified. These aren't the limits of what's possible. They're just the limits of what we've discovered so far. And here's the truly unsettling part. We've only explored an infinitesimally small fraction of the universe. We've examined a few thousand stars in detail out of septillions. We've sent probes to a handful of planets in one unremarkable solar system. The universe is billions of light years across. It contains more stars than grains of sand on every beach on Earth. And we've barely scratched the surface. Which means the facts I've shared today, as strange and impossible as they seem, are probably ordinary compared to what's still out there, waiting to be discovered, waiting to violate our expectations again. The universe is not obligated to make sense to us. It's not designed for our comprehension. It just is. And the more we learn about it, the stranger it becomes. So the next time you look up at the night sky, remember, you're not looking at empty space dotted with points of light. You're looking at a cosmos filled with diamond planets and iron rain, and voids that shouldn't exist, and asymmetries we can't explain. You're looking at a universe that is far stranger, far more beautiful, and far more terrifying than anything science fiction ever imagined. And we're only beginning to understand it.